Now that we know the definition of the standard matrix for a linear transformation, in this video you're going to learn how to actually find the standard matrix. And there's two steps, essentially. The first step is to compute what the linear transformation, in this case we'll keep the name t, compute what the linear transformation does to the standard basis vectors. So you'll plug in the standard basis vector e1, the standard basis vector e2, and then you'll keep on going until you get to your last standard basis vector. Once you compute all that, you take what you found in part 1, the new vectors, and form a matrix with those columns. Now let's actually compute one. I want to find a matrix for this transformation, and this is a transformation of the plane from R2 to R2, which reflects vectors across the line y equals x. In order to do this, we'll want to take a look at a picture of what's going on. I've drawn in the line y equals x, and then the two standard basis vectors here are the red points. E1 is on the x-axis, E2 is on the y-axis. So what the reflection does is it picks up this first standard basis vector and reflects it across the line, and we actually end up at the other standard basis vector. So E1 gets reflected to E2, and the same thing happens with E2. We start here, we reflect through the line, we end up at E1. So off to the side here I've made a note that T of E1 is E2, T of E2 is equal to E1. With that information we can form the standard matrix. We need the two columns, T of E1, T of E2, and now I've written it out. T of E1 was E2, so that's 0, 1, and T of E2 is E1, so that's 1, 0. Now here's a question for you to think about a little bit. What kinds of reflections, and for this question let's just stick to an easy situation, so the plane, what kinds of reflections are actually linear transformations? So give that a thought, see if you can come up with an answer.